Hello, everyone, and thank you for joining us for today's webinar, Why You Should Be Using Docker MultiStage Docker Builds in 2019. Today's session is brought to you by CodeFresh Live, and today we'll see how you use multi-stage Docker builds and the best practices around them, even taking a Docker image from 700 megabytes down to 20 megabytes, which is a big difference in the context of CI/CD. Our presenter today is Guy Salton, Solutions Architect at CodeFresh. And as we are going through the presentation, you may enter questions. Please remember to submit them in the Q&A box on your Zoom toolbar so that we can better keep track of them, and we'll address them at the end of the presentation. This session is being recorded, and a link to the recording will be sent to you later this week. Please remember to reference codefresh.io/events for our upcoming webinars, as we have fresh, informative webinars for you every month. So that is all for the housekeeping items. Guy, if you want to come on the line, the floor is all yours.
Thank you very much, Taryn. And welcome again, everybody, and thank you for joining. So as Taryn mentioned, today's webinar will talk about multi-stage Docker builds and why you should use them in 2019. Just to introduce myself, my name is Guy. I'm a solutions architect here in CodeFresh, helping with technical POCs, overviews, installations, and providing our customers with technical service. And you have my email here, so you can feel free to send me any emails if you have any questions during the webinar, after the webinar. We'd love to talk. So let's get started. First, I want to start with why are we talking about multi-stage Docker builds only now? And that was also the topic of the webinar, why you should be using them in 2019. So for those of you who maybe know, multi-stage Docker builds are available starting from Docker version 17.05, which was released in 2017, so a while ago. So why are we talking about this now? The thing is that we in CodeFresh, we see a lot of our users' usage and how they use Docker. Some of them are just moving to Docker, some of them are using Docker for a while, and it seems like a lot of our users and also other people that we meet are still not using multi-stage Docker builds, and that's a shame. We'll see why it's a shame in this webinar. Here on the screen, you actually see a screenshot from Reddit with a recent post that was just like, I think a week ago, which talked about using multi-stage Docker builds to reduce container size. And it got a lot of traction and a lot of reviews. And you can see some of the comments that people had here, like, whoa, that's amazing. I was looking for a solution to reduce my build, my image sizes, and that's so cool. So it seems like people are not yet fully familiar and aware of multi-stage Docker builds, and that's why we decided to have this webinar to help everybody out and utilize this great feature of Docker. So let's start with just going over quickly what is a Docker file and a Docker build. I guess that for you joined, probably most of you are familiar with Docker images, but just to quickly go over this. So Docker file, Docker provides us with an imperative DSL as text, so we can create a list of build commands. Each of these build commands will generate one layer, and the whole Docker file, we usually create one Docker image. So this works great, and this is the basics of Docker, and we'll see an example of that. So again, one Docker file will create one image. Let's look at an example. And here we can see an example of a Docker file that is building an image for Go. So of course, to run my application, I first need to build it and compile it. So you see that I'm starting, and of course, every Docker file will start with a from command, and this is where which image it will use to initialize and start with. And this can be any Docker image. It can be a custom one, it can be an official one. Here I'm using Golang version 1.71. And the first thing that I will do is copy all of my source directory into my Golang container, and then run go build to build and compile my Go application. After the build is done, I'm exposing this container with port 8080, and finally running the binary to run my Go web server. So let's see how we can build such a Docker file and run it. So we'll go into our first demo. And by the way, you can see this public GitHub repository that you can use. You can even access it now and follow up with our demo. So it contains the Docker file that I just showed you, which is what we're going to use now. So this is again our Docker file. I have it saved in one of my folders, and I'm going to now build it in the terminal. So it's simply called Docker file, right? I can see it here. So this is my Docker file. Now to build it, I'll run docker build -f to specify the Docker file name, which is simply Docker file. Then I'll add the -t to provide the name of my image, and I'll simply call it my Go app, and click enter. So this will build my my Docker image, and I see that it was built. It used some of the layers from the cache because I built it before. Now I can run docker run to run my application. I can simply run a container with the port that we exposed, which is 8080. So docker run -p, exposing my port and specifying the image that we just created. And I see that my web server is starting at the port that I configured. So we can now open a browser and go to our local host at this port, and I see that my Go application is running. So that was an example of looking at the classic Docker file, building it and running it, and I see that everything looks okay. I can now kill this container. And if I go back to my browser and refresh, see that now my server is down. So we can go back to the slides and continue. So everything worked fine. So what is the problem? Well, there is a problem. And the problem is this. The image that we wanted to run our application should have contained only the binary of my application and some runtime and configuration that are necessary for running my Go web server. But what we got is an image that contains not only my application and runtime, but also a compiler, the build tools. It can, in some cases, contains things like debugger and test frameworks and Git and stuff like that, which should not be part of my production image. And it also makes my image much, much, much larger. So if we go back to the terminal, actually, and we look at the image that we created, right? So I run docker images and grep my image name. I see that the size of this image is 678 megabytes. Okay, so pretty large because it contains all these build tools. By the way, let's just delete the second image as I want to build it live with you. So I'll just run docker rmi and delete this one. Great. So again, we saw that my image is almost 700 megabytes, and that's a problem. And by the way, all these additional libraries and tools that are part of my image can also expose my image to security vulnerabilities, which of course I don't want to happen on my production image. So what can be the solution for this problem? Well, a basic solution can be, let's separate our Docker file and create two Docker files. One that will build my image, contains all my build tools and compilers and debuggers and test frameworks, etc. And one which will contain only the runtime. But this, first of all, makes me manage and maintain two Docker files for the same application. And also, I'll have to figure out the orchestration between these images, like using bash or makefile, something like that. So not a very good solution. The good news is that I don't have to use this solution because Docker released MultiStage Build. So what is MultiStage Build? For those who don't know, it's a feature that Docker released, as we mentioned, in 2017, which lets me create multiple images from a single Docker file. So I will only have to have one Docker file with the same syntax. They just expanded the syntax a little bit, as we'll see in a minute. And I'm running the same Docker build command as before, but it will create multiple stages. So the main concept is that we will start with the first stage that will contain all of our build tools and debuggers and compilers and test frameworks, etc. And this image will probably be big, like we saw on the demo, like it can be 700 megabytes or even more. But the final image, which will, what we will use in production, will be a very minimal image that will contain only the runtime, our application binaries, and nothing else, not Git, not test frameworks, not compilers, no build tools, none of this stuff. So it will be lightweight, and it will be fast to build, it will be fast to deploy, and it won't contain any unnecessary security vulnerabilities. So how will this look like? Let's look at an example of a multi-stage Docker file. So the first thing that maybe comes to your eyes is that you now have multiple from commands. As previously we only had one from command, now we have multiple ones. So that's one of the features of Docker multi-stage build, that you can run multiple from commands, and each of these from commands will create another stage. And this stage can then be exported into a different image. So we're starting from, in this example, from an Alpine, a light Alpine image, and we're tagging it as base. So this is the extension of the syntax that Docker added. So each from command, you can add the as syntax to tag it with a name, and then you can refer to this name in other from commands, as we'll see in a second. So I'm doing from Alpine, then I'm adding a CURL to this image, so this will be base. Then I'm creating another image, which I'm marking as second, and I'm running some command here, so to write some text to some file. Then I'm having a third from a statement, and I'll mark it as third, and here I'm writing some other text. And finally, I have my final image. And here you see that the from is from base. What is base? Base is this image that we created internally. So base is Alpine 3.5 plus CURL. And now the second extension that they did to the syntax, first one was adding the as to the from command. Second one is that you can now copy from a previous image or a previous stage. So I can use the from base, but now I'm copying some files that were created in the second image and other files that were created on the third image, and this will result in my final image. Now let's see a real example of Docker multi-stage build, and we'll see an example that makes sense. So if we go back to our terminal, let's look at this Docker file. And this Docker file, again, will run the exact same application as before. So let's see what's different. It starts with the same Golang image, same version, but this time I'm tagging it as build environment. So this will not be my final production image. This will be my build environment image. And again, I will copy all of my source code into the container. I will build my Go application. So far, very similar to the previous Docker file. But now you see that I have another from command here, and I'm starting from scratch. And for those of you who don't know scratch is the smallest possible image that you can start from, and it basically doesn't contain anything. It will only contain what you copy to it. So I'm going to then, in the next line, copy from my build environment image from this previous stage where we actually built and compiled our application. I'm going to copy the binaries and the runtime configuration, and finishing with exposing this image to port 8080 and running the actual binaries. So let's see how this will look like. And I see some questions. So Scratch is an image. You can use it as an image, but it again doesn't contain anything. You can start from any image here, and we'll see other examples. But the idea is to start from a very, very lightweight image that doesn't contain, you know, any unnecessary tools, and so it will be fast and secure. Now let's see how we can build this this multi-stage Docker image. So again, I'm in my folder, and I previously built this Docker file, but now I'm going to build this Docker file, dockerfile.multistage. So again, to build it, I'm going to run docker build -f to specify the name of my Docker file, but this time I'm going to specify dockerfile.multistage, and again add the -t to specify a name of my image. So I'll call this image my Go app multistage and run. So I see that my image is now built. It was built and tagged successfully. And if we now look at our images by running docker images and grabbing the my Go app name, I see that this new multi-stage image is only 5.6 megabytes. So we went from 678 megabytes to only 5.6 megabytes. And that's because we don't have all of our build tools and compilers in our production image. We only have what's really, really necessary, which is the runtime and the actual application binaries. Now let's see if this even works, right? So we can run docker run, again exposing my port, and this time specifying the new image that we built. And I see that this web server is now starting. I can go again to my browser and go to localhost, to my port, and I see that my application is running. So you see the same functionality, but a much, much, much smaller image. So faster, more secure, and much less storage. So now we can go back to our documentation, to our slides. And it's important to note that maybe some of you are not using Go, or you're using Java or Node or PHP. You can enjoy multi-stage build with any programming language, not only Go. And we actually have some really cool examples for that in our documentation. So you can, let's click on Java, for example, and see how it will look like in Java. So exactly the same concept, right? To build and compile your application, you will start from an image that has the build tools, has the compiler. So here we'll start from Maven with an image that contains JDK version 8, and we will mark this as Maven toolchain. And then we can go and copy the source and build our image using Maven. But then for the final production image, we will not use this Maven with JDK, as we don't need all this tooling. We will use a very lightweight Java image that contains only JRE based on Alpine. So it will be much, much lighter. It will be built faster, and it won't contain any unnecessary tools and test frameworks that may be exposing us to security vulnerabilities. So that's the main concept. One more thing that I really encourage you to check out is this blog post that we created about Docker anti-patterns. So as we've been working here with Docker and containers for a long time, and we see sometimes our users, or we see people that are simply, they started using Docker and because everybody's doing it, or they heard of the advantages that it has, but they're not maybe using it correctly. So there's a lot of do's and don't do's here in this article. And one of the points here is exactly on what we talked about, where people, and I think it's point number 4 or 5, exactly, confusing images that are used for development with those that are used for deployments. So the actual deployment image should contain only the compiled form plus runtime dependencies and nothing else, really nothing else. It shouldn't contain any test frameworks and any compilers or anything like that that you use for development. So really encourage you to check that out in our blog of CodeFresh, right? You can just go and Google Docker anti-patterns. So that's great. And now I also, I don't know if I mentioned it at the beginning, so we talked about a Docker build and the problem with it and how we solve it with multi-stage Docker. Now I want to introduce CodeFresh and talk a little bit about how multi-stage Docker builds can help us as part of CI and CD processes. So for those who don't know CodeFresh is the first container native CI and CD platform for microservices designed for Kubernetes. So what is container native means? It means that if you look at this diagram, for example, that shows you a classic CI/CD flow where you start from maybe a commit and then go through a multi-stage build. You can build or install your Helm charts and then run some integration, performance, security tests in parallel, then push your artifacts, your images into some registry, and finally deploy them to production. In CodeFresh, each of these steps will run inside a Docker image. So as a Docker container, so you get a segregated environment for every step. You don't have to maintain a build slave and pre-install all of your tools on this slave. So it's really simplifies the CI and CD process. And it's also a very intuitive and friendly SaaS platform. So we can go and see a demo on CodeFresh on how to utilize multi-stage builds. So let's go and open our browser, and maybe some of you are actually seen this before. So this is the CodeFresh UI. So again, it's a SaaS platform. You can go and sign up for free, get a free account. And what you'll see first is your project view. So you can create multiple projects, and each project can then contain multiple pipelines. And I created this project, which is linked to the same Git repo that contains the project that we built and ran locally on my terminal. So we can go and start with this pipeline. And this is how a pipeline looks like in CodeFresh. You see that it's built using a declarative YAML file. I can either build it here in line, or I can import it from my Git repository. And this simple pipeline contains only 2 steps. The first one is git clone. It will clone my Git repository. So I'm specifying the repo that I would like to clone and the branch. And the second one is going to build our image. So we created a library, a marketplace of steps that you can use. A lot of them are around using Docker containers and stuff like that. So to build a Docker image, you don't have to run those Docker commands explicitly like I did locally on my terminal. I can just set the type of the step as build, choose the image name that I would like to get, and point to the Docker file that I have in my repository. So once I ran this pipeline, I can look at the builds, which are the executions of this pipeline. So we can look at one of them, for example, and see that the two steps were executed successfully. So I was able to clone my repo and then build my image. Now here I can see the logs of my Docker build, and you can see that actually all of the layers were pulled from the cache. As CodeFresh has a pretty unique caching mechanism that can really make your builds faster. So the way that it works is that every pipeline gets a persistent volume. So once you run your pipeline for the first time, all of your project files will be automatically placed on this volume. And also it utilizes Docker cache. And it has out of the box caching on the intermediate layers of the Docker image. So as long as I don't change my Docker file, it will just reuse all of my layers from the cache. But if I make only a small change to the end of the Docker file or something like that, it will still take all the existing layers from the cache and will only build the new ones. Now, if we go back to our project, and we can look at the second pipeline that I created here, and this is for the multi-stage build. So you see that CodeFresh has out of the box support for multi-stage build. All I had to do is simply specify the name of my Docker file. That is a multi-stage Docker file here. And other than that, it's exactly the same build. And if we look at this build, for example, we see that the whole execution was only 18 seconds, right? It was much, much faster. And I can see here the logs of my multi-stage build, again, utilizing the cache. Now, the cool thing about this is that you also get a free private Docker registry with every account, even with the free account. So once your images are built as part of your CI flow, they are also automatically pushed to your private Docker registry, and you can go to the images view and see your images here. So again, I see that the My Go app image, which is not utilizing multi-stage, is 646 megabytes, while the multi-stage one is only 5.37 megabytes. And so this is the full V2 registry, and I can even click on each of these images, and that's the really cool part here, is that I see all kinds of information about this image, like when it was created, if it was promoted to another registry, and I can even here from the UI go and push it to other registries that I have connected here to CodeFresh. But I can also go and see the Docker file itself. If you remember, it's the first Docker file that we built locally, right? Not utilizing multi-stage. I can see the logs, which will show me the pipeline that built this Docker image. So I can see when did it run, I can see the duration of this execution, and I can go and go to the actual pipeline configuration for this image. And finally, I can also even see the layers of this image. So it very nicely give me a visual representation of all of the layers that were created. And look, it's at all of these layers, and you can even see the size of each of the layers, and you can expand each of the statements here to see exactly what happened on each of your layers and understand how your image got this big. So this image, if you remember, is 646 megabytes. Now, if I go to the multi-stage image, right, I see the same information. I see the Docker file that is using multi-stage build. So I have two from statements and the actual image that was built, which is only 5 and something megabytes, started from scratch and only copied the binaries and runtime that were needed to run this application. And if I look at the layers here, look, only 3 layers. And that's why it's so lightweight, it's so fast, it's much, much more secure. All of those labels, by the way, for those who are not familiar with Docker labels, labels is something that you can add to your Docker file, and it's simply adding metadata to your image. So CodeFresh by default also add things like the branch, so I can know exactly for this specific image, as it was built as part of a CI flow, which branch did it come from, what's the repo name, who is the owner of the repo, what's the commit SHA, etc. And if you remember at the pipeline, at the Docker file that I showed you here, see you can add your own labels. So here I added this label saying that this image is the second image and this image is the third image. Right, so you can add your own labels, and then you'll see them here as well inside of CodeFresh. So that's, you know, you saw these different in the sizes also on your CI and CD, and you saw the difference in the build sizes. And of course, if you then decide to deploy your image into Kubernetes, for example, or ECS or Fargate or any service like that, of course, deploying a lighter image will be much, much faster. It will be more secure, as it won't contain any unnecessary build tools, compilers, debuggers, test frameworks, etc. So that was a little bit about running multi-stage builds and, you know, the advantages of multi-stage builds as part of CI and CD. One more thing that I want to show you is utilizing the target parameter. And what does this mean? So sometimes there are some cases where you'll have a multi-stage build and you won't necessarily want to use only the final image, right? Because if you think about it, or we can think about this example, we started from this Golang SDK image, which is big, right? When it contains all of my build tools. And then the final image that we got was only this scratch one that, you know, only has the runtime and application. But what if I still want to use the image that was created here? Or what if I have more than 2 from statements like here, and I decided I want to use this image? So Docker also provided a solution for that. So you can pass something called a target to your Docker build command, and then specify which stage you want to use. So by default, it will use the last stage, which is the final image. But if you want to maybe get, let's say I want to get the second image, then in CodeFresh, you see in the build Docker image step, I can add a target parameter and specify the value of this target parameter. And if we look again at my image, at my Docker file, I see that I labeled this second image as second. So this will be my target. So I can now go and say, okay, I want to clone my repo, build my image, but as a result for this Docker build, I want to get the second layer and not the final layer. So if I now look at the execution of this build, I see that the clone happened successfully. Now, if I look at the build of my Docker build, right, I see that it started from Alpine version 3.5 as base, right? That was the first command, right? This. Now it should add the CURL to this base image. So I see that it's adding CURL, right? Now it's continuing and it's running the second from statement, which is from Debian as the second image. And that's it. You see, image is up to date. It's running the echo hello, sorry. Echo hello, hello, as my second image does. And finishes with having the label. So it doesn't go and continue, and the rest is just labeled. So it doesn't go and build the other stages, as I stopped it on the second stage. And I can also see a representation of that if I go to the images view. We can go and add multi-stage example, right? So I can go and I see this image is big, considerably big, right? 108 megabytes, as it was not the final and light image. And if I look at the layers, I see that it has the image second layer, as this is the second image, the image that was produced from the second stage. So this is how you use that. You can see a lot of information about, what are all the functions of the Docker build inside of CodeFresh, and again, examples from different programming languages right here. So if you go and look at our pipeline steps inside the YAML, we can go and look at our build step, which is our native Docker build step. And it shows you all the usage, so how to specify a target, how to add build arguments. Of course, you can add any logical conditions on when do you want to run this step, etc. And you have the list of all the possible parameters here. So we refer to this target branch, target parameter. I guess in some cases, people in their origin image, let's say Golang or Maven, etc., they say, okay, I already have my build tools there. Maybe they added some test frameworks there and debuggers and stuff like that. Maybe they would want to use this image for running tests or stuff like that. So they can run a build. Docker build, specify the target as, specifying the base image as the target, and then running their test frameworks, etc. You don't have to do that. You can just, I always believe in, having exactly what you need for your specific action and nothing else. So you can just have, usually you will have your images that you use for CI, like images that are made for running tests, images that are made for security scans, and images that help you with deployment. But these are not relevant to the production image. The production image should contain, again, only the application, the runtime, and the configuration that will enable and let your actual pipeline, your actual application run. So let's just go. So we saw the demo on multi-stage in CI/CD. So just to summarize before we go into the Q&A, we saw that using one Docker image for both the build and the production results in slow deployment and a lot of security vulnerabilities. So this is definitely something that is not recommended. And again, we talked about the Docker anti-patterns blog that gives you all the do's and don'ts. MultiStage Build produces a lean, secure, production-ready Docker image. So you saw a much lightweight, much more light, much faster to build, much faster to deploy, and much more secure. And with CodeFresh, you get speedier builds thanks to the caching across all images and layers. So again, the basic Docker cache, but also caching on the intermediate layers of the Docker image with native support for multi-stage. So thank you again very much. As I mentioned, you can sign up for a free account and you literally get unlimited builds with the free account. So we don't limit you on the amount of builds whatsoever. You can go and sign up for free and start running your pipelines. So I think we'll go into the Q&A session right now, and let's see.
Awesome. Yeah, thank you so much, Guy. We do have a couple questions, and just a reminder, if you have any questions that you haven't entered yet, please put them in the Q&A box, or if they were in the chat and they haven't been answered yet, I want to make sure they don't get lost. So please add them to the Q&A button on your Zoom toolbar. So first of all, we have a question from Jag. We have a Docker WebLogic image that has 1.5 gigabytes. Would multi-stage builds work for this?
So it can work. Definitely depends on what exactly the image does. So if it's built similarly to what we've seen on the webinar, where you're starting from an image that has build tools, it has compilers, it has debuggers, it has test frameworks and all this stuff, and then you're building your app, and only at the end you're exposing it at some port and running it. So of course multi-stage build can help you there, because you can just add another stage that will copy only what's really necessary from the build into a very lean, lightweight image like we've seen here that will run in production. And then this can definitely reduce the image size that you have in production now.
Great, thank you. And then our next question is there a possibility to run similar CodeFresh environments on premise?
Yes, that's a very good question. So CodeFresh, as we mentioned, is a SaaS platform. We also have a full on-premise offering where you can install the whole CodeFresh application on your own environment, on a Kubernetes cluster that can be behind the firewall and completely disconnected from the internet. But there is also a third solution, which is becoming very popular, which is a CodeFresh runner. And that means that you can say, let's look at one of our pipelines that I showed you earlier. Here in the settings, you decide where this pipeline will run. So by default, once you sign up to CodeFresh, by default, all of your pipelines, all of your builds will run on a cloud-hosted environment that we host, CodeFresh, and it's a Linux environment. But if you have some internal assets that you need to access as part of your builds behind the firewall, let's say you have like an Artifactory registry behind the firewall, or you have like a Bitbucket server behind the firewall, and running those builds on a cloud-hosted environment outside of your network simply won't be able to connect to your internal assets. So you can install a CodeFresh agent on your own cluster behind the firewall, like you see that I did here, and it will simply add another option here in the runtime environment. And then it will even let you manually increase and decide what will be the resource allocation for your builds, because the builds will run on your environment. So this can be a good solution.
Awesome, thank you. And our next question, how can I do pod auto scaling when its CPU is above 50%?
So this is a little bit off topic, but with CodeFresh, by the way, you can look into this. We have a native deploy step. So if you look at all of these steps here, there is also a deploy step. And if you're looking for auto scaling and deploying to Kubernetes, this is also something that we support natively. Again, if you have high CPU, that's something that we need to look into and see exactly how. But this is a little bit off topic, more on like Kubernetes scaling, and yeah, that's about that.
Okay, sounds good. Thank you. So let's see our next question. While defining standard-based Docker image for an organization with all basic required artifacts, do you think we can leverage Docker multi-build features? Can you give us a use case on how this could be used when it is published for all IT teams to use?
Can you repeat the first part of the question again?
Sure. While defining standard-based Docker image for an organization with all basic required artifacts, do you think we can leverage Docker multi-build feature?
So yeah, it really depends on what you want your end image to contain. So if you have some image that you need to use across different IT teams, and you need this image to contain build tools and compilers and other test frameworks and stuff, then obviously, as you'll need this stuff, and this stuff can be pretty heavy, and then there is no escape from that. But if you currently have all those tools in your image, but you don't really need them on the image, like if you use this image to deploy to production, and it's just like a web server or some application that runs and doesn't need all those extra tooling inside, then definitely you can use MultiStage Build. And of course, again, if you have some specific example that you want to show me, you can send me an email then, and we can look into it exactly to that example.
All right, thank you. And then I have one more question. And so just a reminder, if you have any last questions, to enter them into the Q&A box here. What limitations are part of the free version? So we do have unlimited builds available, but I don't know if you want to pull up our different pricing structures there real quickly, Guy.
Sure. So that's a good question. And as mentioned, with the free plan, you get unlimited builds. And we actually changed our pricing pretty recently to make it very, very simple. So you see that every account gets unlimited builds, you get unlimited private repositories, and you get one small runtime machine. So basically the price, there are two main factors that affect the price: the size of the machine that you're going to run on, and the number of concurrent builds. And we actually have those calculators here, so you can just play around with them and understand what will be your end price. But you get a small machine for free, which means that you can run builds on an environment that has 1 gigabyte of RAM and 2 cores of CPU. If you see that you need to run multiple builds in parallel, like let's say you have a development team of like 10 developers, and you want to use Git triggers so that every time that a developer commits something to his repo or open a pull request, a build will run and trigger automatically, then you probably need more than 1 concurrent build. And this, of course, can affect the price and also the size of the machine. So let's say if you want to run, I can show you an example of that. If you want to run multiple steps in parallel inside of the same pipeline. So let's say you have an application that contains multiple microservices. By the way, CodeFresh is also built on the microservice architecture and contains about 20 microservices. So let's say you want to build all of them in parallel. you can add like a parallel step to your pipeline. And if we look at, just showing you a relevant example for that, then for that you will need probably a stronger machine. So here I'm running 4 Docker builds in parallel, right? And I want them to run fast. Then I'm running a security scan on each of these images in parallel, then deploying to staging and finally to production. So for multiple steps in parallel, you'll probably need a stronger machine. And it even has some recommendation here. So up to 4 concurrent steps, you can use the medium machine. If you need more than that, you can go with the large. And we mentioned the hybrid solution earlier, which is installing this runner on your own environment behind the firewall, as well, along with other enterprise features that will be part of our enterprise packages. So if you need features like SSO or RBAC or SAML behind the firewall support, on-premise Git providers, stuff like that, or you need to use CodeFresh on-premise, then this will be part of enterprise.
Awesome. Well, thank you so much, Guy, and thank you everybody for attending today. You can look for our future webinars at codefresh.io/events, and we hope to see you at our future CodeFresh live events. Have a great day, everybody.
Thank you.